Assalamualaikum and good day to all the judges. My name is Fatin Syakirah binti Halim from Unimap. So today I would like to share about our product, which is a sensitive microRNA biosensor based on carbon quantum dot CQD for early detection of COVID-19. And this is the list of the inventor. So first of all, I would like to give a brief overview for this product. So this product is a biosensor for COVID-19 diagnosis. So the sensing element for this biosensor was made up from the interdigit electrode as a transducer, carbon quantum dot as a nanomaterial, DNA probe as a bioreceptor, and target is a microRNA of the SARS-CoV-2. So detection occur due to the hybridization of the microRNA and also DNA probe that lead to the production of the current signal that could be detected from the picoammeter. Okay, now we move to the introduction. So, what is COVID-19 actually? COVID-19 is a coronavirus disease 2019 is a novel emerging human infection disease that caused by severe acute respiratory syndrome coronavirus 2. And the primary transmission of the COVID-19 is from the airborne, direct contact and also indirect contact. As for the symptom, it can be ranged in the mild to the severe. For the mild symptom, the patient of COVID-19 can be experienced of loss of appetite, loss of smell, and also has a shortness of the breath. While for the severe, the COVID-19 could give a ARDS effect to the patient that lead to the death. So, this is the full genome of the SARS-CoV-2 virus, and this full genome can be extracted out from the gene bank, and this is the reference number of the virus. Okay, so for now, for our biomarker, for this biosensor, we use microRNA from the N region of the SARS-CoV-2 genome. So why we use N region? This is because N region is more conserved, means that it has a fewer nucleotide variation or mutation compared to the other region, especially S region. Other than that, it also expressed abundantly during infection. So it lead to the highly sensitive target for our biosensor for detection of the COVID-19. For the problem statement is about the current detection mode for the COVID-19. So currently, COVID-19 diagnosis is involve three types of the assay. First is the molecular assay, number two is serology assay, and number three is the imaging. So for the molecular assay, we use a qRT-PCR, and it is a gold standard for the detection of the RNA virus. It is also for the early infection. However, it has a time-consuming, demand for skilled personnel, and has a high false positive and negative result. While for the serology test, it is used for the late infection, so it cannot be used for the early infection of the COVID-19. And for the CT scan, it is used to see the image of the lung that been infected for the COVID-19. However, this CT scan is a non-selective tool because it cannot differentiate the pneumonia caused by the SARS-CoV-2 or the other viral pneumonia. So we move to the electrical biosensor. So this electrochemical biosensor use the principle of the hybridization that lead to the simple, fast, high sensitivity, and quantitative measurement for detection of the SARS-CoV-2 virus. Okay, now we move to the microRNA. So why we use microRNA as our biomarker instead of the RNA? Okay, from the literature review, RNA virus, including coronavirus, can encode microRNA. So this microRNA is a stable RNA that can circulate in our body fluid. So it lead to the less invasive sample. The main reason why we use microRNA is because we want to cut down the detection time of the SARS-CoV-2 virus. This is because microRNA can be detected using a direct method, which means that without the RNA extraction. So it lead to the reduce the detection time. Other than that, microRNA can be discovered at the early of the beginning of the infection. So therefore, it can lead to the super early detection of the SARS-CoV-2 virus. Okay, so now we move to the nanomaterial that we use in our biosensor, which is the carbon quantum dots. So, the carbon quantum dot has a certain band gap that is suitable to use as an electrode modifier to accelerate charge transport and also enhance the conductivity of the electrode. It also has a huge functional group that is a benefit for the immobilization of the DNA probe. So it leads to the highly selective biosensor. Other than that, actually CQD can be synthesized using a green synthesis from the waste such as lemon peel waste, pineapple peel waste. So it leads to the inexpensive material that give a good future for our biosensor. So for the novelty of this product is the involve the non-invasive sample because of the using of the virus microRNA as a biomarker. Other than that, it also has a shorter time detection due to the without RNA extraction and also highly sensitive and cell-active biosensor. Other than that, it also use a low feed volume for the sample, reusable due to the generation of the DNA probe, and also has a compact system because of the interdigit electrode that we use, which is the microelectrode that we can reduce the size of the biosensor. For the product description, so this biosensor is actually the nanomaterial IDE based biosensor for detection of COVID-19. So it may use the virus microRNA as a biomarker and also carbon quantum dot as a nanomaterial to enhance the conductivity of the biosensor. The sensing element and the detection strategy is the IDE surface was modified by the CQD, followed by the immobilization of the DNA probe through uptest as a linker, and then the hybridization between the microRNA, which is our target, to the DNA will produce a current signal that lead to the detection of the SARS-CoV-2 virus. So this is the flowchart of the SARS-CoV-2 detection analysis. First, we have to design the probe first using bioinformatic tool. Number two is the development of sensing element that include the CQD, IDE, and also the DNA probe. Number three is the electrical measurement by using Catley. And number four is the sample measurement. So the total detection of the biosensor, we can reduce it from the 33 minutes if using RNA to 5 minutes if using microRNA. This is because the direct method that we use is non-involve the RNA extraction that make the shorter detection time for the SARS-CoV-2 diagnosis. So this is the advantage for this biosensor. First, it allows for early, rapid, and sensitive detection. Number two, it involves the non-invasive sample due to the direct measurement of the microRNA. Number three is a fast, low-cost detection. Number four is it allows for the POC application due to the direct measurement and also the types of the electrode that we use. Number four is it has a high trial output analysis and response time through the high sensitive biosensor. As for the commercialization, this biosensor is beneficial for early detection of COVID-19 that effective for the safety monitoring. It also can be is an improvement for the detection of the COVID-19 previously, and also can help to prevent the further outbreak by the super early detection of the virus. So this is our marketing target, which include the KKM, New City Research Lab, private medical diagnostic and testing lab, government hospital, and also individual. So this is the project timeline for this biosensor. Now we are in the stage 2, which is the development of the biosensor and also the clinical trial. So this is the list of our collaborator, Mr. Ang from the HTF, Dr. Ifa from MGI, Dr. Farah from Varak, and also Mr. Tang from the Rapid Genesis. Okay, this is the list of the publication and award for this biosensor. Okay, last but not least, I would like to thank you to my supervisor, Dr. Nur Azizah Parmin, for her guidance and also support, encouragement to us to complete this development of the biosensor for COVID-19 detection. So that's all from me. Thank you. Have a good day, everyone.